Okay, welcome back to the video, and we're going to be talking about doing some actual practice problems with local max and mins, and we're finding critical points that we've talked about before. So this whole video is we're practicing finding critical points and maximum and minimums. Okay, so here's the steps that you do. First, you take the first derivative of your function. Then you're going to set f prime of x equal to 0 and solve for x. Also, if necessary, find where f prime of x is undefined. Now this won't happen especially much at first, but it will happen. Then you're going to create a sign chart, which we call the f prime bar. Where f prime of x changes sign, we have local max and mins, and then we're going to check it with the first derivative test. All right, so I'm going to model to you how it works. Have your graphing calculator ready so you can check things and go along with me. But basically, I'm going to go through each one. So I actually have this function, y equals x cubed minus 12x minus 5. And it's cubic, and it's positive, so I know my right tail is up. I have 2 turns in it. And if I asked you to graph the derivative, you would end up having only 1 turn in it. But I'm not asking you to graph the derivative. We're going to actually find by calculus where the max and mins ends. Now, if I look at this graph, I see right here this looks like a local max and this looks like a local min. So basically what you're going to be doing is calculus to back up what you think might be true. So the first step is to take the first derivative. So I'm going to change this to f prime of x instead of y. This is really f of x, so I'm going to change it to f prime of x equals, and this is an easy one, 3x squared minus 12. There is our first derivative. Okay, so the math is pretty easy. Set it equal to 0, okay, and then we're going to solve for x. That's step 2. So set it equal to 0. When I do that, I can factor out a 3. So I have x squared minus 4 equals 0. And then I see I can factor it some more. So I have 3 times x plus 2 times x minus 2 equals 0. And then I'm going to do a huge big T. 3 will never equal 0. X plus 2 can equal 0. X minus 2 can equal 0. X equals negative 2. And x equals 2. All right, so I have solved for x. Now this is the x value of our critical point. All right, so I'm going to do a little chart here where it says local max, which I mean by maximum, and I'm going to do local minimum. Now I don't know anything except that I have x is at negative 2 and x at 2, something's happening. So what I want you to do is after you do a sketch of the graph, which I already have here, we're going to do our f prime bar right underneath it. And since we found that the slopes are 0, because if you look at it, the slopes are 0 here, the slopes are 0 here, at negative 2, so right here if I was going to graph it, it would cross there. I'm going to come down here and say, okay, negative 2. And then here at 2 is our other point that we found. Now I want you to go in and see where your function is increasing and decreasing. So if I pick a number to the left of negative 2, let's say negative 3, I'm going to come back up here to my factored version and I'm going to kind of quickly plug in a negative 3. If you want to do this, you could actually put this yellow into your graphing calculator and look to the right of these points and you would see, and you're looking at just basically what the signs are. So if I put a negative 3 in here, I'd have 3 times a negative 1 times a negative, so a negative times a negative is a positive. So to the left of this looks positive here. And if I look at my graph, it is, my slopes are increasing. Now I want to go from negative 2 to 2. So I'm going to pick a point in between. So I'm going to pick a 0, come back up to this yellow. If I put a 0 here and a 0 here, I'd have a positive times a negative. So it would be negative slopes in between here. And it does look like my function is decreasing. So this shows my function is increasing. This shows my function is decreasing. And then I'm going to put a 3 in here. Positive times positive is positive. Okay? So this should look familiar to you because we've done this. So that's interesting that we know that, but I want to know what a local max or local min is because these are critical points, okay? So I'm going to say, well, if my slopes are increasing and then decreasing, this is the first derivative test, this is a local max because I don't have a closed interval, so this is a local max. My slopes here are decreasing, then increasing, this is a local min. okay? A minimum, if you will. So I know now my local max is at negative 2 something. I know my local min is at 2 something. How do I find the something? Well, what you're going to do to find the y is you plug it back into your original. So my original is y equals, and then I'm going to plug in the negative 2. Negative 2 cubed minus 12 times negative 2 minus 5. When I do that, y comes out to be 11. And I know it shows here on the graph, but I want to show you where it comes from. So this is negative 2, 11. And if I plug in the 2 cubed minus 12 times 2 minus 5, I'm going to get y equals a negative 21, which it shows here on the graph also. So it doesn't matter, but I've got 2, negative 21. So I've completed. I found my critical points. These are my critical points, my local max and my local min. You don't use global unless you have a closed interval. Okay, so there's one. All right, let's try another one. Okay. So now I have this graph here already done. It does not have any closed intervals, so it has arrows here. That's important. I want to find my critical points. So first thing I do is f prime of x. And if you'll notice, I picked easy functions for the power rule because I want to show you the concept behind it and not worry too much about the algebra, and then that will get harder. So I did 3x squared minus 12x minus 15 using the product rule, the power rule. Now I'm going to put it equal to 0. This one's factorable. I'm going to take out a 3. So I have x squared minus 4x minus 5 equals 0. 3, this is going to be x minus 5, x plus 1 equals 0. I'm going to make a huge T to factor. 3 will never equal 0. X minus 5 will equal 0. X plus 1 equals 0. So x equals 5. And x equals negative 1. Which I could kind of tell by looking at this right here and right here. Looks like my points there for max and minimum. So I'm going to set it all up. Local max, local min. Okay, I don't know which one is which. I have a kind of a good idea, but we're going to have to back up everything with calculus. So there's my f prime bar. So I see at 5, so here's our 5, and here at negative 1 is our x values of our critical point. So now what I want to do is see which one's which. So I'm going to go to the left of negative 1. Of course, you go to the factored derivative one, this one here in yellow. I'm going to put a negative 2 in there. So that would make it negative times negative, so it's positive. Between negative 1 and 5, I'm going to pick 0. Negative times positive, so that's negative. And then here I'm going to pick 6. Positive times positive is positive. Again, you can put this first derivative in your calculator and just look at your table and look at the signs of your slopes. So if this goes from positive to negative, this is a local max. If it goes from negative to positive, this is a local min. Now it's very important that you do this little part right here. Very important. Because this is basically your first derivative test. So we're doing the first derivative. We found where the x values where our slope is 0. Then I'm seeing, okay, is it a max or min? And I wouldn't even have to look at the graph and still figure it out. But I like having the graph there so you can see. And then I said, okay, so at negative 1 is my local max, so it's negative 1 something, and my local min is 5 something. Where do I find the something, the y value? Well, we plug it back into our original. So if I take f of negative 1, actually back into our original, it's going to be negative 1 cubed minus 6 times negative 1 minus 15 times negative 1 plus 36. So when I do that, f of negative 1, the actual point on the graph, comes out to be 44. And you know what? I had someone one year just put the original in their graph and looked at the table. That next is a local min. So now we're going to do f of 5. And when I do f of 5, I get a negative 64. So I'm just plugging a 5 in here. So I get a negative 64. And I just found my two critical points, my local max and my local min. That's it for these two problems.